8.4 is about angles of elevation and depression. So the first thing is just getting you used to that vocabulary. So I gave you a scenario over here. Suppose a person on the ground sees a hang glider at a 38-degree angle above a horizontal line. So here's this person. They see that hang glider, so this would be an angle of elevation. So you're looking for that horizontal line. The line that's going up is going to show me that it's an angle of elevation. So then at the same time, let's say a person in the hang glider sees the person on the ground at a 38-degree angle. So here's my horizontal line. Slanted line is going down, so that would make it an angle of depression. So the first thing is just getting you used to that vocab, making sure you can identify what kind of angle it is, whether it's an angle of elevation or depression. So here is my first picture, and it's wanting me to decide what angle 1 is. So here is angle 1. My horizontal line is here. The other side is angling down, so that means it'd be an angle of depression. Now I went a step further and described what that angle is representing, so I just said from the bird to the person in the hot air balloon. You do not have to do that, you just have to identify if it's an angle of depression or elevation. So then the next one is angle 4, which is down here. Here's my horizontal line, the other side is going up, so that means it'd be an angle of elevation since that second side is elevating up. Okay, pause the video and see if you can do the got it question. So in the got it question, it's asking you to use the same picture in problem 1, and it's asking me to describe angle 2. So here's my horizontal line. This top line is angling up, so that means it's going to be an angle of elevation. And then angle 3 is angling down, so that would be an angle of depression. Again, I took it a step further and described from what point the angle started to the other point. You don't have to do that, you just have to tell me if it's an angle of elevation or an angle of depression. Okay, so now the math part of it, here's where it connects to our trig functions, because now we're going to be using angles to find missing side lengths. So here's our first scenario. Suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. So here I am, here's my angle from my eye level. Your eye level is 5.5 feet above the ground. So here's my triangle that they gave me, but this is me seeing it, so I also need to incorporate this 5.5 feet that they also gave me. Approximately how tall is the turbine from the ground to its hub? So notice that they're giving me a right triangle, so I can use those trig functions since I have an angle in there. So I'm looking at, here's my angle. The two sides that they give me are opposite and adjacent of that angle. So that tells me that I have to be setting it up using tangent. So I would set it up as a trig function. So I would do the tangent of 56.5 equaling my ratio, which would be opposite over adjacent, so x over 53. So here is my equation. Remember, we want to times by 53 since this is division, so that these 53's will cancel each other out. So x ends up being by itself, and then I can just plug this into my calculator. So when I plug it in, I get approximately 80.1 feet. Now, keep in mind, that is from this point right here to the turbine. Remember that it's asking me from the ground. So remember that I also have to add to it that 5.5 feet that is from my eye level to the ground. So once I had my answer, I need to come back and add 5.5 feet to get my actual total. So I added this 5.5 feet plus my 80.1 that I just found was that piece right there. Okay, see if you can do a similar question on the got it. So pause the video. Okay, in the got it question, eye level again is 6 feet above the ground, so I went ahead and put that into my picture, and then it's wanting me to find the height from the ground. So I'm going to represent x from eye level to the climber. So I see what ratio it's going to be setting up as. Here's my angle. The two sides to that angle would be opposite and adjacent, so again I would want to use tangent. So I did tangent of 32 equaling x over 1,000. To solve, I would times both sides by 1,000. So when I do that, I take 1,000 times the tangent of 32 and I get approximately 624.9. Then I need to add to that my 6 feet to get to the ground, so I just add 6 to that, so I got 630.9 feet. So the tricky part with this is just making sure you know what the picture looks like, and then also making sure you can incorporate what that eye level might look like. Okay, last question here. So now we're going to be using an angle of depression. Now the difference between the two is angle of depression will not be inside my triangle, so we'll have to do some inferring to figure out some missing angle measurements. So pause the video for a second and just read through the problem, and then when you're ready, push play. So now that you've read through the problem, let's take a look at what we have here. It tells me that the pilot must begin at 3 degrees descent. So that means that this angle right here is angle of descent, so that would be 3 degrees. Then it says it's also starting at a height of 2714 feet. So that's above sea level. So I know that right here I'm at 2714. Then it says the airport is at 1,007 feet above sea level. So I marked that here. So I know from, so it's wanting me to find to the nearest tenth of a mile how far the runway is the airplane at the start of this approach. So that tells me that it's wanting from here to the airport how much that would be. So first thing is trying to interpret what the picture looks like. So trying to put in those numbers where you think they go is a battle of itself. Then the next part is whenever you have an angle of depression, notice this angle is not inside my triangle. However, I do know that when I have parallel lines here, these alternate interior angles are the same. So since this angle is 3, that means this angle is 3. So every time you have an angle of depression, you're going to have to make sure that you rewrite it somehow or figure out how these angles correlate into your triangle. So now what I know is that if this is at 1,007 above sea level and this is at 2714, if I subtract the two, I would find the difference so that I could find this side length of this triangle. The reason I need a side length is because right now I don't have any, so I need at least one to help me find this other missing length. So now I compare my two side lengths with my angle, and I notice that I have an opposite over hypotenuse, so that tells me I'm going to be using sine. So I do sine of 3 equaling 1707 over x. Now this is a problem where you have to times by x to get it out of that denominator so that these x's cancel. So that'll leave me with x times the sine of 3 equaling 1707. Then you have one more step where you need to come back and divide by the sine of 3 in order to get x by itself. So then when you divide, those sines of 3 will cancel out. So you can type this in your calculator and do 1707 divided by the sine of 3, and I end up getting 32,616.2 feet. Now this is a very challenging problem because of just the way it's set up, and then also we're not quite done there because the question asks to the nearest tenth of a mile. So I was in feet, so to convert that I would need to know how many feet are in a mile, and there are 5,280. So I would need to divide those to convert it to the correct answer, which is in terms of miles. So my correct answer would be 6.2 miles. Just an FYI, I may not necessarily give you quite advanced problems like this where you have to do so many calculations, but you will have problems like the got it question where you kind of have to set up the problem in a visual and then try and figure out how it correlates to an angle of depression or elevation. So why don't you pause the video and see if you can do the got it question. Okay, so in the got it question, here is my picture that I set up. So I have my airplane and it sees a life raft down here at 26 degrees. So remember that's an angle of depression. So here's my horizontal line that the airplane is driving through. This would create that angle for that 26 degrees. Then it says the airplane's altitude is 3 kilometers. So that tells me straight down I would be at 3 kilometers, and then that's how I end up getting that right triangle. Remember when you have an angle of depression, it's not inside your triangle. but you do know that alternate interior angles are congruent, so I do know that now down here by the life raft, that angle would be 26 degrees. So now I can set up my ratio. This would be using tangent since I have an opposite and an adjacent side. So here would be my equation, tangent of 26 equaling 3 over d. I would have to times by d on both sides in order to get that d out of the denominator. Then I would have to come back and divide by the tangent of 26 so that I can get d by itself on that left side. So I would type into my calculator 3 over the tangent of 26, and I get 6.2 kilometers. So just an FYI in terms of level of difficulty. This top problem that we worked through is pretty challenging. I would not expect for you to do all of that by yourself. However, I would expect for you to try and set this up and be able to do like the got it question by yourself, because I do understand half the battle is just making sure you have the picture correct. Alright, see if you can then start the assignment, otherwise begin some extra practice on the practice worksheet that I gave.